Hey, good day, everyone. So today what we're going to do, we're going to talk about double angle and half angle identities in trigonometry. So we're getting into section 7.2. So what we're going to do, I'm going to go over the formulas that we're going to be playing with, and then we're going to do some example problems that utilizes these formulas. So with these formulas, something to keep in mind, this is going to be a little different than 7.1 and 7.3, as in we're not necessarily going to be proving these identities. We're going to be using these identities to rewrite various trigonometric functions. So the first one, the first double angle identity that we have is sine of 2 theta, or sine of 2 times your angle. And that's equivalent to 2 times sine of your angle times the cosine of your angle. The next one that we have is cosine of 2 times your angle. And that's equal to cosine squared minus sine squared. But then we also have 1 minus 2 times sine squared of your angle. And then we also have 2 times the cosine squared of your angle minus 1. Now, cosine of 2 theta, 2 times your angle, there's 3 different formulas you can use, and it does not matter which one you choose because they're all still going to get you the same answer. The next one that we have is tangent of 2 times your angle. And tangent of 2 times your angle is equal to 2 times tangent of your angle, all divided by 1 minus tangent squared of your angle. Okay, so that one is a little bit trickier to use, but we're going to be doing a problem like that in just a little bit. Now we also have the half angle identities. Now there's a couple of them down here, and these are a little bit trickier to use, and we're actually going to start off our example problems with half angle identities, and then we're going to make another video in just a little while with double angle identities. So sine of your angle over 2 is equal to plus or minus the square root of 1 minus cosine of your angle divided by 2. Okay, that's your half angle identity for sine. The half angle identity for cosine is cosine of your angle over 2 is equivalent to plus or minus the square root of 1 plus cosine of your angle over 2. And that's the half angle identity for cosine. For tangent, there's 2 identities you can use, and it does not matter which one you choose. Excuse me. So the first half angle identity for tangent is sine of your angle over 1 plus cosine of your angle. That's also the same thing as 1 minus cosine of your angle over sine of your angle. Now, something to keep in mind too, kind of a trick to remember the sine and the cosine. If you look at the sine half angle formula, you notice that there's a subtraction sign. Okay, so sine and subtraction, they start off with the same letters. So that's how you're kind of able to, I guess, memorize those first 2 formulas and just differentiate which one is which. So sine is the subtraction, and then what's left, cosine is the positive. Okay. And also too, the plus and the minus on the square roots, it all depends on what quadrant your initial or your half angle is in. Okay, so that's what we have to remember, those first, second, third, fourth quadrants. All students take calculus. There's also another saying for it, which is not really PG, but there is another saying for it. So if you are curious, you are more welcome to reach out to me, and I'd be happy to tell you. So yeah, use those quadrants, use those signs, use that knowledge that we did back in chapter 6, and that's where the plus and the minus would come into play. So now let's take a look at some example problems. Okay? So the first one we have, find the half angle value for the following function, sine of pi over 12. Okay, so for sine, okay, remember we're having to use the formula sine of your angle over 2 equals plus or minus square root of 1 minus cosine of your angle over 2. Okay, remember that's the half angle identity for sine. So, but wait a second, I don't know what pi over 12 is. That's where half angle identities come into play, because it allows you to rewrite the function using values that we've known previously, specifically the values on the unit circle. So what I mean by that, let me erase this. Okay. What I mean by that, we can rewrite sine pi over 12 over 2. Okay, that's by using the half angle identity. Now, if we simplify this complex fraction, remember with a fraction, when you're dividing, you keep the first one the same, change the division sign to multiplication, and flip the second guy. Keep, change, flip. Coming back from algebra. This actually simplifies down to sine of now pi over 6. Hey, guess what? We're familiar with pi over 6 because that's on the unit circle. All right, so now we can utilize the half angle formula and start figuring out where our what our angles are. So whenever we're doing the half angle identity, okay, the half angle identity, the angle that we're going to be using is that pi over 6. Let me try something better. So whenever we actually do the arithmetic, we're going to be using that pi over 6 value. So what that means is that we'll have plus or minus, we'll get to that in a second, the square root of 1 minus cosine of pi over 6 divided by 2. And that's all on the inside of the square root. Okay. Now, plus or minus 1 minus, and then cosine of pi over 6, if you remember from your unit circle, is the square root of 3 over 2. All right, let me get that square root out a little bit better. Yep. All right. So really, from here on out, we just did the trig. Now it's the algebra. That's the fun part. So in the first part of the fraction, on the top part of the fraction, on the inside of the square root, we've got to combine fractions. We got to combine whole numbers and fractions. Excuse me. So we got to find the least common denominator. The LCD, in this case, would be 2. Okay, you got to pull it back from 1020 or 1021. So your LCD would be 2. So that means when you rewrite these fractions, on the top, it would be 2 over 2 minus the square root of 3 over 2. All over 2 still. All right. So let me pull that guy up real quick. So at least you can follow my arrows to see like what the process is. Oh, still plus or minus. So on the top there, okay, now we can combine the fractions. So now we would have 2 minus the square root of 3 over 2. And then the whole thing still over 2 with a plus or minus on the outside. Just like we did with the half angle one at the very beginning of the problem. We have a fraction divided by a number. Anytime we do division with fractions, remember, keep, change, flip. So we keep the top guy the same, change that big division bar to multiplication, and then we flip the second fraction. Okay? So that means, all in all, it would be 2 minus the square root of 3 all over 4. Just a little shortcut. This 2 on the bottom, when you change it and flip it, it gets multiplied by this 2 on the bottom of this one. So that's where the 4 would come from. Okay, yet again, still algebra. Now, if you remember your rules of square roots, when you take the square root of a fraction, it's the square root of the top divided by the square root of the bottom. Okay, so that means we'd have the square root of the top over the square root of the bottom. You guys see where I'm going with this one? Because we have plus or minus square root of 2 minus the square root of 3 all over 2. Okay, and that would actually be your final answer, except that plus and the minus out there. Okay, now where the plus and the minus come in, it really doesn't matter where you take the plus and minus into account. For me, I like to get all the hard stuff done and then take care of the easy stuff. The reason why I'm saying that is because if we look at the original angle, the pi over 12, what quadrant is pi over 12 in? Quadrant 1. And if you remember, all students take calculus, all trig functions in the first quadrant are positive. So therefore, that would actually be a positive square root. Okay. Well, you don't have to have a positive sign there. That's okay. So that would be your final answer. Okay. So just to recap, we got to find the half angle of pi over 12. So we divide it by 2. And that's where we get the pi over 6 from. Then we utilize the pi over 6 in the actual half angle formula. That's what we're using for all the work. And then after that, it's algebra from there on out. And we do a lot of simplifying by using the rules of division with fractions, properties of radicals. And that's where we get the final answer, the square root of 2 minus the square root of 3 over 2. All right. Now, let's take a look at another problem here. All right. So given that sine is 5 pi over 12 is equal to 0.9659, and cosine of 5 pi over 12 is 0.2588. Use the approximate function values to find the other 4 function values for the other function values for 5 pi over 12. All right, now this one it looks tricky. It really does, but it's actually easier than what you think. And the reason why I'm saying that is because we don't have to look at the decimal numbers. We have the angles right there. We have our angle A. So we can just throw out the decimal values, out the window and don't even look at them. So really here, let's see here. Okay, so yeah, at least for tangent, we don't really have to look at the decimal numbers. There we go. I had to think about that for a second. We do have to utilize the decimal numbers for the secant and the cosecant because we don't have a half angle identity for secant and cosecant. But that's the easy stuff. We're going to get to the tangent one first. So we have the angle 5 pi over 12. Now, there's 2 formulas you can use for the tangent one. Okay, there's 2. We're going to utilize, what do I have? 1 minus cosine of your angle all over sine of your angle. Okay, so that's the formula I'm going to utilize. You can utilize the other one, and let's see if we get the same answer. All right, so let's figure out what the angle that we're going to be playing with is. All right, the only reason why I'm erasing is because I try to utilize as much room as I can. So your angle that they give you is 5 pi over 12. And then because it's a half angle, we got to divide it by 2. Okay. Now, because we have an angle, it's a fraction, it's division, we keep change, flip it. So that means we would be dealing with the tangent of 5 pi over I just realized there was a mistake in my problem. I'll be darned. No, wait a second. Hang on real quick. Aha! I tricked myself up. Now, how I tricked myself up on this one, okay? When I did the half angle, the angle is 5 pi over 12 over 2, which means if I would have done that flip, that would have been 5 pi over 24, which makes it even worse, okay? That's why I hesitated. And it's good that I hesitated. You know why? Because this problem actually requires us to work backwards. I caught myself on that one. So no, I didn't actually make a mistake. I just wasn't thinking, which happens a lot, okay? So we already technically have the half angle already. We just need to figure out what the original angle was. Okay, that's what I'm saying. It's having us to require to work backwards. So basically, I was correct in saying that it is tangent of 5 pi over 12. Okay, but we need to figure out what angle divided by 2 gave us 5 pi over 12. That's the whole point of, that's the whole process of us having to work backwards. All right, so the angle divided by 2, that gives us 5 pi over 12. All right, that would be the tangent of 5 pi over 6 divided by 2. Okay, because 5 pi over 6 divided by 2, when you keep change flip it, that's where you get the 5 pi over 12 from. Okay, that's where I kind of messed up at first. Okay, I hesitated, and I'm glad I did. So now we get to work with the 5 pi over 6 because 5 pi over 6 is actually in our unit circle. All right, so when we do the tangent formula, remember I had 1 minus cosine of my angle divided by sine of my angle. Okay, remember that's the formula I'm utilizing. So I would be doing 1 minus cosine of 5 pi over 6 divided by sine of 5 pi over 6. All right. Now, cosine of 5 pi over 6. All right, so let's see here. 5 pi over 6, that would land you in the third quadrant. Right? Let's double check. When in doubt, you can always double check. Yeah, that gives you 150 degrees. Okay, so 150 degrees is in the third quadrant. Cosine of pi over 6, the exact value would be square root of 3 over 2. But since it's in the third quadrant, that means it would be 1 minus a negative square root of 3 over 2. All right. Sine of 5 pi over 6, because 5 pi over 6 is in the third quadrant. Okay. Third quadrant. Sine is negative in the third quadrant. Right? Because tangent is the only thing that's positive in the third quadrant, tangent and cotangent. So that means it would be divided by a negative 1/2. Okay, so because sine of 5 pi over 6 is 1 over 2. Okay, now keep going with this because now we got the algebra to play with. That means we would have 1 plus the square root of 3 over 2 divided by negative 1/2. Right? So yeah, it's algebra from here on out. So I'm just going to continue back on the left side. On the top part of our fraction, we've got to add and subtract fractions with whole numbers, so least common denominator. That would be 2 over 2 plus square root of 3 over 2, all divided by negative 1/2. I'm not going to deal with that negative 1/2 until the very end. So just a little FYI. So on the top there, we would have 2 plus the square root of 3 over 2 divided by a negative 1/2. All right. So now, dividing fractions, keep, change, flip. But this time I'm going to write it all out. So that would be 2 plus the square root of 3 over 2 times a negative 2 over 1. Okay. The negative sign doesn't change to a positive. Okay, that happens every now and then with students wanting to change the sign to a positive or negative. Okay, signs don't change. It's only flipping. Keep, change, flip. So these 2's cancel out. Okay, they divide out. So all we're left with is a negative 2 plus the square root of 3. Right? You can keep it like that. My math lab may want you to distribute that negative sign into the parentheses. So it could be a negative 2 minus the square root of 3. All right. And so whatever decimal value that is, that's actually what my math lab would want you to put it in. Okay, because they want the approximate function values. So whatever decimal number that is, you can just throw that straight into the calculator, and that's where your function value would be. Okay. Now we found the sine. Well, we're given the sine, the cosine, and the tangent. Now we got to figure out the other three. But here's this is the easy part. Okay. All right. Here's the easy part. Sine. Okay. They give you the sine is equivalent to 0.9659. The reciprocal values that we covered back in the last section, okay, reciprocal values, cosecant is the reciprocal of sine. So the cosecant of 5 pi over 12 is equal to 1 over 0.9659. Okay, and then whatever decimal number that would be. So 1 divided by 0.9659, 1.0353. Okay, remember, cosecant is the reciprocal of sine. So you do 1 over the value of sine. That's where we got that value from. All right. And then secant is the reciprocal of cosine. So that would be 1 over 2.2588. Okay, so that would be approximately 3.8639, give or take. Okay, and whatever rounding issue that would be. All right, and then to find cotangent, because I didn't write the approximate value of cotangent, it would be 1 divided by that value that you found for cotangent, or that value for tangent. So the cotangent is 1 divided by negative 2 minus the square root of 3. So whatever value that would be, whatever decimal value that would be the approximate function value for cotangent. Okay, so yeah, we're having to utilize formulas that we learned back in in section 7.1 to do this problem. Okay, so let's take a look at another problem. Okay, so this one, and this one is the, oh, actually I did them all. Oops. So yeah, I had it broken up like that. So yeah, yeah, the tangent, this was going to be the cosecant, this one was the secant, and this one was the cotangent. Okay, so I did all the problems actually on one page, which actually is right here. Okay. So on the next video, we're going to talk about the double angle identities. So these right here with the half angle identities. Okay. So tune in next time for the double angle identities video, and just let me know if you have any questions. See you guys later.